Welcome to episode 03 of the Junior Estimator Training Series. Today, we're tackling Division 03, Concrete. Concrete isn't just ordering ready mix. It's a 3-in-1 trade combining formwork, reinforcement, and placement. In this complete guide, we'll walk step by step through calculating concrete volume in cubic yards, formwork contact area in SFCA, and rebar tonnage. We'll also look at placement methods, from boom pumps to direct chutes, and how to account for specialized surface finishes and hardeners. Finally, we'll cover how to price edge case contingencies and cross-division handoffs so you never miss a hidden cost. Let's dive in. Concrete is the backbone of structural estimating. It is one of the most volatile divisions on a project bill of quantities. Market fluctuations can break a project's budget instantly. Estimating Division 03 isn't just ordering mix. You are actually balancing 3 simultaneous trades inside a single scope. You have formwork measured in SFCA, reinforcement in tons or pounds, and ready-mix concrete in cubic yards. Combine all 3 with your labor placement crew. Miss any single element, and your structural budget falls apart. Let's break down the 2 critical structural subcategories of Division 03, concrete reinforcing. Section 0310 covers formwork, measured in square feet of contact area, slab shorms, column clamps, release agents, and form reuse factors. Remember, formwork can represent up to 50% of your total structural labor cost. Section 0320 covers concrete reinforcing, measured in tons or pounds. Your takeoff must capture rebar sizes from #3 all the way to 18. Don't forget to account for lap splices, chairs and ties, welded wire mesh, fiber reinforcement, and high-strength post-tensioning cable tendons. Four pillars of a professional Do3 concrete takeoff: formwork, rebar, mix volume, and placement. Let's break down how to calculate each one step by step. Pillar number 1 is formwork SFCA. Calculate your total surface contact area. Factor in the labor difference between gang forms and timber forms. Pillar number 2 is rebar tonnage. Convert your linear foot lengths per bar diameter directly into weight, and always add a 10/5 allowance to cover lap splices and waist hooks. Pillar number 3 is mix volume in cubic yards. Start with your net geometric volume, then add a 5 to 10% waste allowance depending on subgrade smoothness and long pump line. Pillar number 4 is placement and finishing. Align your labor crews with the right placement method, whether that's a direct chute, line pump, boom pump, or crane bucket. Ordering exact net concrete volume on a job site is a guaranteed way to run short mid-pour. Welcome back to the Cost Architect. Today we are breaking down in the cubic yard takeoff formula.
Takeoff formula, including why an 8% standard waste allowance can save your job site from catastrophic delays.
Calculating concrete volume seems simple on paper, but ready-mix orders are rarely just length times width times depth.
When you are calculating orders for unformed earth-cast footings or elevated deck slabs, ground-over excavation and formwork deflection will eat up your material fast. To compensate, estimators must use an adjusted volume calculation formula that incorporates real-world site conditions rather than neat line drawing dimensions.
An 8% standard waste allowance is your baseline protection against subgrade unevenness, spillage, and pump line holdup.
Use this checklist to ensure no costs are overlooked. Consider seasonal weather impacts, verify crane and pump access, price specialized admixtures, and define surface finishing tolerances like FF/FL numbers. Understanding unit rates is vital. This table illustrates standard daily outputs and labor hours per unit for common tasks, such as foundation walls, slab finishing, and rebar installation. The concrete lifecycle workflow follows 4 stages: initial form and rebar installation, the critical pre-pour inspection, the placement and strike process, and finally, the essential finishing and curing phase. Placement methods significantly impact your budget. While direct chutes are the most cost-efficient, they rely on site access. Conversely, crane buckets or high-rise boom pumps offer flexibility, but come with higher equipment and operational costs. Time is money when tracking concrete strength gain. Understanding that concrete reaches 65% strength at 7 days and 100% by 28 days helps you determine the optimal time to strip formwork without risking structural integrity. Remember the estimator's structural principle. Concrete will get hard and it will crack. Your job is to ensure every joint, rebar tie, and formwork tie is priced to manage these realities effectively. We have covered the essentials of Division 03. In our next video, we will transition to structural masonry walls in Division 04. See you then!